In today's video, we're going to learn about the product to sum and sum to product formulas. So the sum to product is when you want to take a product of two trig functions and write it as a sum of some trig functions. So for example, if I want to take the sine of u times the sine of v, I would use the formula that is equal to 1/2 times the cosine of the angle u minus angle v minus the cosine of angle u plus angle v. Cosine of u times cosine of v can be rewritten as 1/2 times the cosine of angle u minus angle v plus the cosine of angle u plus angle v. A way to help you remember this is if you're taking the product of the functions of sine times sine or cosine times cosine, when you do the sum formula, you're going to have cosines. For the sine times a sine, you will have a minus in between your two angles. It would be a difference. And for cosine times cosine, you'll have a plus between your two angle measurements in your sum formula. If you're finding the product of two different angles, such as sine of u times cosine of u, your trig function is going to be sine. So this formula is going to be 1/2 times by the sine of angle u plus angle v plus sine of angle u minus angle v. And if you're taking the product of cosine u times sine u, the formula is going to be 1/2 times this sine of angle u plus angle v minus the sine of angle u minus angle v. So a good way to remember this, if you're taking the product of two different trig functions, which is sine times cosine, and sine is first, then you're going to have the sine formula, and you want to have a plus in between. If you're taking cosine times sine, and sine is second, you're going to still use the sine function, but you're going to have a minus in between. Also, please notice that when you're taking the product of the same trig function, you have a u minus v as first, and when you're taking the product of two different trig functions, such as sine times cosine, it's u plus v first. One hint I would tell you is before applying this product to sum formula, I would rewrite my product so my larger angle is written first. It just makes it easier and you have to deal with less negative angles, and it's easier to evaluate these on the unit circle when they're positive. And we will use this a lot in calculus class, so we're just kind of introducing the topic this semester. So let's try our first example. I want you to rewrite the product sine of 4x times cosine of 5x as a sum or difference. The first thing I notice is that my larger angle 5x is written second. So I'm going to rewrite this so that it's cosine of 5x times sine of 4x. So I'm going to use that last formula we talked about when I have this cosine times sine. And so I'm going to use the sine is going to be my trig function, and it's going to be a minus in between. So the formula I'm going to use is 1/2 times by the sine of my 5x plus the 4x minus sine of 5x minus 4x. Okay, simplifying that down, 5x plus 4x gives us 9x. And 5x minus 4x gives us x. So this is a legit answer, but usually you'll separate the terms and rewrite this as 1/2 sine of 9x minus 1/2 sine of x. Okay, we're going to rewrite the product sine of 5x cosine of 3x as a sum or difference. So I have a product of two different trig functions, and sine is my larger angle, so it's written first. So I'm going to use the formula that has sine with a plus sign between. So it's going to be 1/2 times the sine of 5x plus 3x plus the sine of the angle 5x minus 3x. That's going to give me 1/2 times the sine of 8x plus the sine of 2x. Distributing the 1/2, I get 1/2 sine of 8x plus 1/2 sine of 2x as my answer. Okay, sometimes it'll be useful to go in the other direction to write a sum as a product. Okay, if you were given the sine of one angle plus a sine of another angle, you would use the following formula. 2 times the sine of angle u plus angle v divided by 2 times by the cosine of angle u minus angle v divided by 2. Now, if you have sine of angle u minus sine of angle v, that'd be 2 times the cosine of angle u plus angle v divided by 2 times the sine of angle u plus angle v divided by 2. Angle u minus angle v divided by 2. I think I said that wrong. Okay, if you have cosine of u plus cosine of v, we have that formula be 2 cosine of angle u plus angle v divided by 2 times by the cosine of angle u minus angle v divided by 2. Now, if I have cosine of one angle minus cosine of another angle, it's negative 2 sine of angle u plus angle v divided by 2 times by the sine of angle u minus angle v divided by 2. So notice that my angles are all the same for all of our formulas here. It starts with u plus v divided by 2 and then u minus v divided by 2. The difference is which trig functions that we use. So when I have cosine of u plus cosine of v and write it as a product, I want to be multiplying 2 cosines together. If I have cosine minus cosine, I'm going to do the product of 2 sines, and I'm going to put a negative in front of my 2. Now, if I have a sine of one angle plus the sine of another angle, that's going to give me different trig functions, and sine's going to be written first because plus gives us a sine first, so it's going to be sine of first angle, cosine second. Now, if a sine minus sine, I'm going to do my cosine angle first times by my sine angle. Okay, this will help us get exact values using our unit circle. So, for example, if I want to find the exact value of cosine of 195 degrees plus cosine of 105 degrees, I could rewrite this using my sum to product formula. And so I'm going to use that third formula that we have, where it's going to be 2 times cosine of adding my 2 angles together, so that's 195 plus 105 divided by 2, times by cosine of the difference of my 2 angles divided by 2, so 195 minus 105 divided by 2. Okay, let's do some algebra here. 195 plus 105 gives us 300. And 195 minus 105 gives us 90. 300 divided by 2 is 150. And 90 divided by 2 is 45 degrees. So now I'm going to look at my unit circle and figure out what the cosine of 150 degrees is. That's in quadrant 2 and has a reference angle of 30 degrees. So it's going to have the same as cosine of 30 degrees, but it's going to be negative because cosine is negative in quadrant 2. And cosine of 45 degrees is going to be root 2 over 2. Multiplying that across, I get root 6 over 2 as my answer. Let's check and see how you did on this problem. Sine of 195 degrees plus sine of 105 degrees. Okay, this is the sine formula. And so I'm going to have 2 times the sine of 195 degrees plus 105 degrees over 2 times by the cosine of 195 degrees minus 105 degrees over 2. All right, we already figured out what 195 plus 105 is 300. 300 divided by 2 we know is 150. So I'm just going to write this as 2 sine of 150 degrees. And we already figured out the subtraction in the last problem. 195 minus 105 is 90. Divided by 2 is 45. And so I'm just going to go to my unit circle. I know the sine of 150 degrees is positive 1/2. And the cosine of 45 degrees is square root of 2 over 2. Multiplying that across, I end up with the square root of 2 over 2. We can also use our product to sum and sum to product formulas to solve trigonometric equations. So in this example, we want to find the sine of 5x plus the sine of 3x is equal to 0. So I'm going to take this sum and write it as a product using my sum to product formula. And in this case, that will be 2 times the sine of 5x plus 3x divided by 2 times by the cosine of 5x minus 3x divided by 2 is equal to 0. Now let's simplify that down and get 2 sine of 8x divided by 2, which is 4x, times by the cosine of 2x divided by 2, which is just x. Now that I have a product, I can use my zero product rule and set the first product, which is 2 sine of 4x equal to 0, and the second factor, which is cosine of x, equal to 0. Solve each of these individual equations. I would have that sine of 4x is equal to 0, And then the angle whose sine is 0, and this repeats every n pi. So then to divide by each term by 4, I get x is equal to n pi over 4. If n is equal to 0, this will give me 0 degrees, or 0 radians. If n is equal to 1, I get pi over 4 radians. If n is equal to 2, I get 2 pi over 4, which simplifies down to pi over 2 radians. If n is equal to 3, I get 3 pi over 4. If n is equal to 4, I get 4 pi over 4, which simplifies down to pi. If n is equal to 5, I get 5 pi over 4. If n is equal to 6, I get 6 pi over 4, simplifies down to 3 pi over 2. And if n is 7, I get 7 pi over 4. If n is 8, I get 2 pi, which is another rotation around the unit circle. Solving the second equation, cosine of x is equal to 0 when x is pi over 2 or 3 pi over 2. So putting this in order, my solution for one rotation around the unit circle to this equation is 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4. You try the next problem. Okay, I'm going to start this the same way. I'm going to change my difference problem to a product problem from here by using our sum-to-product formula, which would be 2 cosine of 4x plus 2x divided by 2 times by the sine of 4x minus 2x divided by 2 is equal to 0. Simplifying this down, I get 2 cosine of, 6x divided by 2, that gives us 3x. And then 2x divided by 2 is x. So 2 times cosine of 3x times sine of x is equal to 0. Using my zero product rule, I can say that 2 cosine of 3x equals 0 or sine of x is equal to 0. Let's start by solving this second equation. I know sine of x equals 0 when x is equal to 0 or pi. And then for the first equation, 2 cosine of 3x, I will divide each side by 2 to get cosine of 3x is equal to 0 degrees. Or the angle whose cosine is 0 degrees, well, the first angle whose cosine is 0 degrees is pi over 2. And then this repeats every n pi because it's quadrantial angles. And so dividing everything by 3, I get x is equal to pi over 6 plus n pi over 3. Now to make this a little bit easier to work with, I'm going to get a common denominator and write this as 6 pi plus 2n pi over 6. And then to evaluate from 0 to 2 pi, I'm going to first let n equal 0. And when I replace n with 0, that second term disappears, so it's just x equals pi over 2. If n equals 1, I get pi over 6 plus 2 pi over 6. Adding that together gives me 3 pi over 6, and that will simplify down to simply pi over 2. If n is equal to 2, I have x is equal to pi over 6 plus, 2 times 2 is 4, so that's 4 pi over 6. Which is equal to 5 pi over 6. Now let's let n equals 3. So plugging that to my original formula here, I get x is equal to pi over 6 plus 6 pi over 6, which is 7 pi over 6. If n is equal to 4, I get pi over 6 plus 4 times 2 is 8, so 8 pi over 6. Adding that together gives me 9 pi over 6, which simplifies down to 3 pi over 2. Now let's let n equal 5, because we still haven't got to 2 pi yet. And that gives me pi over 6 plus 10 pi over 6, which gives us 11 pi over 6. Now, next one will be 12 pi over 6, so we are definitely, that's as close we can get. So those are all those angles. Now putting all of this together with my last solution and this solution here, my final answer from 0 to 2 pi of this series is 0, pi over 6, pi over 2, 5 pi over 6, pi, 7 pi over 6, 3 pi over 2, and 11 pi over 6. And this is how you can use product to sum and sum to product to solve trigonometric equations.